2NO plus Br2, it is going to give me 2 moles of NOBr. 2 moles of NOBr. Okay. So they are saying that when 0 point, for this, first of all, you have to understand that for 2 moles of NO, we need 1 mole of Br2. Okay, fine. And they have given the number of moles of NO. It is equal to how much? 0.087. And number of moles of Br2, it is equal to 0.0437. Yeah, correct. Are mixed in a closed container at constant temperature and at equilibrium. At equilibrium, we have 0.0518 mole of NOBr. Okay, 0.0518 moles of NOBr. Okay. Now, in this question, you just had to use stoichiometry. You know about stoichiometry? No? What? आपकी आवाज नहीं आ रही, बहुत धीमी आ रही है आपकी आवाज.
No, sir.
इस फर्स्ट चैप्टर में है ना stoichiometric calculations. You have been given number of moles of reactant and you have been given number of moles of product. नहीं आइडिया आपको आयशा?
No, sir.
Okay, listen here. Let us keep this aside. Okay, let us keep this aside. See this chemical reaction. Now this chemical reaction, it is saying that if I will have 2 mole of NO and if I have 1 mole of Br2, I will have 1 mole of Br2. It is going to give me 2 mole of NOBr. You understand this much? Yes or no, Aisha?
Yes, sir.
You understand this much? Okay, fine. Now let us say I'm giving you only one thing. I'm giving you, I said that there are 4 mole of, I have got 4 mole of NOBr. Then how much Br2 would have reacted? Tell me.
4.
नहीं देखिए. See, whatever number of moles of Br2 we are taking, double that NOBr is formed. Yes or no? See the ratio?
Yes, sir.
है ना? So उसके हिसाब से बताइए आप. Now you tell me, if I will have 4 mole of NOBr, then how many moles of Br2 would have been consumed?
2.
2 moles. Very good. है ना? It's fine. 2 moles would have been consumed. Okay. Now see. I will make here the initial. So initial they have been given. NO is how much? 0.087 and Br is how much? 0.0437 and NOBr is nothing. Now in the change you don't have anything, right? In the change you don't have anything. You will just say that you will, here you will write minus of 2x and here you will write x and here you will write what, how much? 2x na?
2x.
2x. Now equilibrium also you have here 0.087. Okay, minus 2x. Here you have 0.0437 minus x. And here how much do you have? See, 0.0518.
0.0518.
Okay. Now can I say that 2x is equal to how much? 0.0518.
Yes,
Now
sir.
x can you find?
Yes, sir.
Now I don't need to do now.
Yes, sir.
Okay. Okay. Because now you can calculate. You will plug in the x value of x here, and you will plug in the value of x here, and then you can calculate what are the equilibrium concentrations. Okay. Now going to 6 point. Okay, fine. Now Samira, your questions. Okay. So you tell me 7.8 में क्या दिक्कत हो गई आपको? आपका असाइनमेंट पता नहीं अपलोड अभी तक हुआ है नहीं हुआ है? नहीं हुआ है तो अपलोड अलग से कर दिया क्या इन्होंने? जी समायरा,
यस सर।
बताइए क्या दिक्कत हुई आपको उसमें? 7.8. Look at the question and tell me ना. हाँ समायरा, क्या हो गया जी? आर यू देयर समायरा?
Yes, sir. Yes, sir.
हाँ 7.8 ना क्वेश्चन नंबर. In that we have a reaction 2 moles of N2. It is going to give me 2 moles of N2O, right? Then they have been given if a mixture of 0.482 number of moles, so they have been given N2. It is equal to how much? 0.482. Then we have O2. O2 is equal to 0.933 moles. In a reaction vessel of volume 10 liters. So volume is 10 liters, so divide by 10, just divide by 10, and I will get the concentration of N2 and concentration of O2. Okay. Allowed to form N2O at which with the Kc is given as समायरा, अब बताइएगा क्या दिक्कत हो गई आपको इसमें, या हम कर दूं
Sir,
सवाल आपका?
I'm not
जी.
understanding the concept.
You are not understanding the concept only. Okay. Like for this question only or for all of the questions?
All, sir.
All. अच्छा ठीक है, देखिए हम आपको बेसिक कंसेप्ट आपको बता देते हैं. अच्छा, आपको इतना पता है क्या क्या देखना है आपको? इनिशियल चेंज इन इक्विलिब्रियम, यस और नो?
Yes, sir.
Okay, so see, as we had this question now, in this question, so you will be given, see, there are 3 things. आप बस अपना ये बताइएगा कि क्या दिया हुआ है आपको. इनिशियल, okay, initial, then there will be change, जिसमें जब like the reaction is happening, and then you will be getting something from the equilibrium. Okay, so how many? Here we have 3 variables: initial, the change is 1 variable, and then equilibrium is 1 variable. So there are 3 variables, out of which 2 will be given to you and 1 will be asked to you. Okay, Samaira?
Yes, sir.
Okay, fine. Now read the question number 8. Read it now out loud. हाँ बोलिए.
Reaction between N2 and O2 takes place as follows. 2N2 plus O2 gives 2N2O. If a mixture of 0.482 mole N2 and 0.933 mole of O2 is placed in a 10-liter reaction vessel and allowed to
Yes.
form N2O.
Wait a second. तो यहाँ पे आपको इनिशियल पता चल गया?
Yes, sir.
है ना? Like just इतना ही बताइए, हो जाएगा धीरे धीरे. You will get it to know. Okay. So you have the initial, yes or no? Like you are
Initial
confident
is
about that? If a mixture of
yes,
0. है ना? You understand the question's language? You have been given the initial.
yes, sir.
है ना? It is given in the question. Now पढ़िए, आगे पढ़िए.
Allowed to form N2O at the temperature for which Kc is equals to 2 into 10 raised to minus 37. Determine the composition of equilibrium mixture.
Okay, fine. So in equilibrium you have 2 things. In equilibrium you have 2 things. You have Kc, that is the equilibrium constant, and you have the equilibrium concentration. So out of these 2, what has been given to you? K has been given to you, and you know that there is a relationship between K and the concentration, equilibrium concentration. Yes or no?
Yes.
Now there is one thing that is missing. The major block that is missing is the change. The change is missing.
Yes.
How much has been reacted? Okay. Now for change, you will always refer to the equation. Okay. Refer to the equation. So what is the equation here? 2 moles of N2, not to the initial concentration, not to the equilibrium constant, not to the equilibrium concentration. For the change, you will just refer to the equation N2 plus O2. It is giving me 2N2O. Okay, 2N2O. So wait a second, let me give some spaces because for the table I need space now. You have N2 plus O2. It is going to give me N2O. No, 2 moles of N2. Here you will have 2 moles of N2O, right? Initial, then change, and then at equilibrium. So what is the initial? Initial, it has been given 0.482 moles, but I will divide that by 10 to get the concentration, yes or no?
Yes, sir.
0.0482, and for oxygen it is 0.0933. Now this has, initially there is nothing. Now according to the reaction, I can write minus 2x. आपको ये आ रहा है कि नहीं आ रहा, ये बताइए आप.
Yes, sir. I got.
What will I write here? I will write minus x here, and I will write plus 2x. Yes or no?
Yes, sir.
Any problem?
No, sir.
No problem. Okay. Now what I will write here? 0. Now the initial, then there is a change, then at the equilibrium you will have 0.0482 minus 2x, and here you will have 0.0933 minus x, and here what you will have 2x. Okay, so what are these? What are these? What are these number? What do they represent, Samaira? नहीं पता. बोलिए. अच्छा, अभी आपको नहीं पता. Okay, fine, no problem. What are these? Tell me.
That is the amount of N2 present.
हाँ, थोड़ा सा उसको और रिफाइन करके बोलेंगे. So it is the initial concentration.
Yes.
Okay, then what are the green part that I have highlighted? That will be the
Equilibrium concentration.
equilibrium concentration.
Yes.
है ना? Okay. Now I can write the equilibrium constant. It is equal to the concentration of N2O to the power 2 divided by N2 to the power 2 and O2 to and O2. Can I write this much? Yes or no?
Yes, sir.
Now you tell me what is the equilibrium concentration of N2O?
2x square.
Yeah, x square, yeah, right. Then अच्छा इतना आता है क्या आपको, या इसमें दिक्कत हो रही थी? Yes, Samara.
Sir, I have like problem and understanding like what to put in which question, like which concept to put like that.
नहीं, कोई ज्यादा concept ही नहीं. We don't have any. अच्छा, यहाँ पे आपको देखिए, I have just said that initial change and equilibrium, है ना? See the previous question. Here also initial change, equilibrium.
Yes, sir.
Right. So उसी तरह what we can do ना? Let me just ask you, like, can you identify what has been given? Initial change and equilibrium. But for sure, equilibrium has two things: the equilibrium constant and the concentration. Sometimes you can also have the partial pressures. Okay, either concentration, or if you have gases, then it will be partial pressure. Okay.
Okay.
So you have these tools that you should always carry. Okay. So something will be given from the equilibrium. Okay. See, in this case, what was given in the question number 9? Na, we were not given the equilibrium constant. We were given one of the concentration. I know. See,
Yes,
at
sir.
equilibrium we have. So something will be given. Okay. Something will be given. You have to trace how to connect. How to see. How did we trace this? From this K, I wrote the initial. I took the initial and the change. And from the initial and change, what did I write? From initial and change, what did I write? I wrote K. And from K, what did I will get? I will get the concentration. So there are links here that you can follow up. Okay. Now let us see what is your next question. So you can do this question now.
Yes, I can.
Okay, 7.11. 7.11. Okay, fine. ये क्वेश्चन थोड़ा सा हो सकता है ट्रिकी हो, मतलब like it's the language that is difficult here. So can you read that?
A sample of HI is placed in flask at a pressure of 0.2 atm at
हाँ, रुकिए
equilibrium.
एक सेकंड. प्रेशर कितना दिया है उन्होंने? 0.2
atm.
atm. ठीक है ना? प्रेशर यही रहेगा. Okay. So they have given what? They have given the pressure as 0.2 atm. So this is going to be the pressure. the pressure of the flask, it is going to be constant, that is 0.2 atm. Okay, 0.2 atm. And then they have asked at equilibrium partial pressure of HI. They have given the partial pressure of HI is, it is equal to 0.04 atm. Now we will have the reaction to HI. It is in equilibrium with H2 plus I2. H2 plus I2. Now you can see that there are 2 moles initially also, and finally also there are 2 moles. So the pressure is not going to change, because pressure, it depends on the number of moles. Yes or no?
Yes, sir.
So pressure is not going to change. That means whatever concentration you have, whatever concentrations you have, the equilibrium pressure will be 0.2 atm. Yes or no?
Yes, sir.
Okay. Now I can say that PHI is how much? 0.04. PHI is 0.04. Now I can see from this reaction, that two moles of HI, and then I will get 1 mole of H2, and then I will get 1 mole of I2. Now they are saying 0.04. Acha, can I say something that the amount of H2 form and the amount of I2 form, it will be equal? If X amount of hydrogen H2 is formed, then X amount of I2 will also be formed. Can I say that, Samaira? No.
Yeah.
We can, na, because number of moles, the ratio is same. Yes, Samaira,
Yes,
tell
sir.
me. The ratio is same. Okay, fine. Now what I can say, that both of these, if I add them, this will be equal to 2x. Yes or no?
Yes, sir.
Then if I add here 0.04, then I'm also adding the reactant part. Yes or no? Because that is the partial pressure of HI at equilibrium.
Yes, sir.
Now this will be equal to 0.2 atm, because this is the pressure at equilibrium. Because
Sir,
this pressure is not going to change. The total pressure, it is not going to change. Now, initially we started with 0.2 atm, and at finally also at equilibrium also we are going to have 0.2 atm. नहीं जी, समायरा बताइए.
Yeah, yes, sir.
है ना? हाँ, this may not have clicked at the first instance. Okay, so just take care of this question. Okay, take care of this question. It's a very small question. Like it is conceptual. It has nothing to do with the numericals. Now you can easily find what is the x, right? You can easily find what is the x. It will be approximately this will be 0.08, I guess. 8 8 16 16 और 4 20. हाँ, ठीक है. Okay. What else do you have? 7.16. The K has been given. हाँ, ये तो आपको मतलब like it is okay. So what they are saying, like you should do this question this way. Wait a second. What is the reaction? You have C2H6. Then what do we have? Gives C2H4 plus H2. Okay, plus H2. Now initially they are saying how many moles? Moles 4 atm. Okay, fine. So we'll have initial, that is 4 atm. This will be 0. This will be 0. Then the change will be 4 minus x. Here the change will be x, and here the change will be plus x. नहीं, एक सेकंड. 4 माइनस नहीं, हम लोग x लिखते हैं ना, माइनस x, और यहाँ पे हो जाएगा प्लस x, और यहाँ पे हो जाएगा प्लस x. सो इक्विलिब्रियम में आपके पास आ जाएगा 4 माइनस x, यहाँ पे आ जाएगा x, और यहाँ पे आ जाएगा x. एनी डाउट टिल हियर? जी समायरा? नो ना? तो इसमें क्या हो गया आपको? अब बस kp लिखना है. सो kp इट इज इक्वल टू, दीज आर दी इक्विलिब्रियम प्रेशर, है ना?
Yes, sir.
अब हो जाएगा. Like you have to calculate for x, because k has been given ना, k आपको दिया हुआ है. This is 0.04. Okay, ATM. So this will be equal to, here we have x square divided by 4 minus x. हो जाना चाहिए अब तो. If you will get the P, then you will get na the equilibrium concentration. You will just plug that concentration in the, है ना? Okay. What else? 16 हो गया ये आपका. 17, 20, 17. Okay. The ester ethyl acetate of formed the non-acetic acid in the, oh, okay. Write the concentration ratio Q for this reaction. तो initial concentrations के बारे में आपको लिख देना था, ठीक है ना? Q लिख देते हैं. अच्छा, कुछ दिया नहीं है, ठीक है. So you can just write the reaction quotient. You can write the reaction quotient, yes or no, Samaira?
So the 16 question is that 2 ICl gives I2 plus Cl.
एक सेकंड देखना पड़ेगा तो. Actually NCERT has, wait a second. अच्छा, 16 क्वेश्चन इज डिफरेंट इसमें भी, लेकिन वही वैसे ही तो है ये भी. क्या हो गया?
Yes, I got it now.
Got
tried.
it? अच्छा. फिर आपका है सवाल 20 में भी one of the reaction that takes place in the producing steel or iron is much reduction of here. Kp is equal to, what is the equilibrium partial pressure of CO and CO2? You will, can you solve this, yes or no? Huh?
No, sir.
नहीं होगा 20. Okay. So they have given a reaction. रिएक्शन इन्होंने बोला है कि FeO है प्लस कार्बन मोनोऑक्साइड गैस है. Then we have Fe solid plus CO2. So initially, अच्छा ये solids ना, these are solids, so they will not come in the equilibrium expression. We will have just the gases. So initially they have given carbon monoxide as 1.4 na, and carbon dioxide as 0.80, right? 0.80. And what is the Kp that they have given? Kp is equal to 0.265. Okay, Kp is 0.265. So first of all, you need to see now we have both something from the product and something from the reactant. So now we don't know now whether the and also this is what, this is equilibrium, right? This will be in equilibrium. Okay, just keep it like that. So now we don't know like the reaction, it is going to be forward or backward. Yes, Samaira? Hannah? We don't know the direction right now. So first of all, can you calculate the direction? What you will do, you will calculate the Q, no? Because this is right now it has not achieved equilibrium. It is the initial concentration. That is why it has not achieved equilibrium, and hence what I will say that Q, it is equal to the amount of CO2, pressure of CO2 divided by the pressure of CO. Now this is equal to how much? 0.80 divided by 1.4 divided by 1.4. So if you calculate this, how much will this be? By 1.4. This is equal to 0.5. 0.571. So what I can say, Q is greater than no? Kp. Now what will happen? Tell me, forward reaction or backward reaction? Backward reaction है ना. Very good, backward reaction. यहीं पे आपको देखिए, यहीं पे आपको क्या करना है, चालाकी दिखानी है कि बैकवर्ड रिएक्शन होगा. इतना हम लोगों ने देख लिया. It will be backward. It will be a backward reaction. Achha, is there any information that they have given? No. Okay, fine. Now that means CO2 will be reduced. Yes or no? And carbon dioxide will increase. What will be getting reduced? Carbon dioxide or carbon monoxide? Sorry, हमने उल्टा कह दिया. CO2 will be getting reduced, ना?
Yes, sir.
So यहाँ पे हम minus x लिखेंगे, यहाँ पे हम plus x लिखेंगे. Do you have any problem?
No, sir.
No problem. So again, by equilibrium, this will be 1.4 plus x, and this will be 0.8 minus x. Now you will write Kp. It is equal to the equilibrium concentration of CO2 divided by equilibrium concentration of CO. So this will be equal to how much? CO2 we have 0.8 minus x divided by 1.4 plus x. Now you can find x.
Yes, sir.
यहाँ पे फिर प्लग इन कर दीजिएगा, हो जाएगा, है ना? तो आपको इतना तो लग रहा होगा कि सब सेम ही है कि नहीं?
Yes, sir. It's same.
हाँ, it is same only. Okay. Like there is थोड़ा सा like background information चाहिए रहेगा. Like total pressure is equal to the sum of all the partial pressure. This is from states of matter. So those information you must be needing, but otherwise it is same only. अच्छा. फिर आपका है 20. Equilibrium constant of the reaction is given at a particular time. The analysis, so the composition of a reaction mixture is this much, this much, and this much. Achha. Again, so here you have been given the, here you, what do you have? The concentration of all the reactants and all the products. Yes or no, Samaira? Question number 20. हम सही पढ़ रहे हैं कि नहीं पढ़ रहे हैं? Question number 20. I have an old book. ये 20 तो हो गया आपका ना? You have 23. Sorry. 23. 23 में किसको दिक्कत थी? और 23 में सारा आपको दिक्कत थी ना? 23 में?
Yes, sir.
Okay, so let us see 23. ये 90% वाला सवाल है ना? 23.
Yes, sir.
ठीक है. What the question is saying that we have a temperature, and at that temperature and at 1 atmospheric pressure, a gaseous mixture of carbon monoxide and dioxide is in equilibrium with solid carbon and has 90.55%. Okay. It is in equilibrium. They are saying that it, ये तो बहुत आसान सवाल था. Okay, fine, not a problem. They are saying that it is already in equilibrium. Carbon solid plus CO2 gas. It is in equilibrium with 2CO gas. 2CO gas. Okay. Now with solid carbon has 90.5% carbon monoxide by mass. Carbon monoxide by mass. So what we can do now? They are saying that the gaseous mixture of CO and CO2 is in equilibrium with solid carbon and has the gaseous mixture ki mass kitna? Okay, fine. So they are saying the gaseous mixture, mass of gas mixture it is equal to how much? Let us say 100 grams. Okay, let us say 100 grams. Now from here I can say the mass of carbon monoxide is equal to how much? 90.55 grams. Okay. Now from here also I can say mass of carbon dioxide will be equal to how much? 100 minus 90.55. This will be 9.45. No, 9.45 grams. Okay. Till here everything is fine.
Yes.
Tell me. Okay, fine. So from this grams, can you convert this to moles? Can you convert this to moles?
Yes.
Yes, sir.
You can convert those moles. Now you have been given temperature, you have been given pressure also. अच्छा, temperature आपके पास है, आपके पास pressure दिया हुआ 180 है ना? So here you have been given the P total, it is equal to 1 atm. Okay, P total it is equal to 1 atm. Now from this information and the number of moles whatever you are getting, can you calculate the partial pressure of carbon monoxide and partial pressure of carbon dioxide? यहाँ से क्या कीजिएगा आप ना, यहाँ से इन दोनों का मोल फ्रैक्शन निकाल लीजिएगा, ठीक है? मोल फ्रैक्शन ऑफ CO and then mole fraction of CO2. Okay. Now you know the relationship between the mole fraction and the total pressure, na? If I will say partial pressure of CO, it will be equal to the mole fraction of CO times P total, and similarly the partial pressure of CO2, it will be equal to the mole fraction of CO2 into the P total. Yes or no?
Yes, sir.
ये याद है कि नहीं, states of matter में था partial pressure, Dalton's law. Basically, but you don't have to worry so much, because whatever the mole fraction you will be calculating now, that will be the partial pressure, because the P, it is equal to 1 atm here. So if you are multiplying 1, it is not going to change anything. So the mole fraction, whatever you had. So now when you have the partial pressures, then what you can do? You can write now. So I assume that you have calculated the partial pressure. Then you can write Kp, it is equal to, what do we have in product? We have CO in product. So partial pressure of CO square divided by the partial pressure of CO2. Okay. Now they have asked what? They have asked Kc. Kp तो निकाल लिया आपने. Kc कैसे आएगा? Kc will be equal to, what is the formula? You have learned the formula is like this, na? Kp is equal to Kc into RT delta Ng. Now use this formula to calculate the Kc. I think they have asked Kc only, na? हाँ, Kc पूछा उन्होंने. ठीक है, this is lengthy, but this is not वैसे concept, कुछ नया concept नहीं है इसमें, ठीक है? It's just that they have included the partial pressure concept from the states of matter chapter. हाँ जी. Anything else?
No, sir.
No, no. Okay, fine. बाकी आपसे हो गया समायरा ना?
Yes, sir.
Okay. So, we were looking at the factors affecting the equilibrium. No? Factors affecting the equilibrium. Now let us write the effect of pressure. Effect of pressure. So again, what let us do? Let us take an example. It is something. Formation of ammonia. M2 plus 3H2 into gas plus 3H2 gas. It is in equilibrium with 2NH3. 2NH3. Okay. So now you tell me what will happen if I will increase the pressure. What do you think? What should happen if I increase the pressure? I mean, the reaction can go one of the sides, na? Change तो होता है, change यही होता है. Like whether the reaction will go forward or backward, on which side? Think about it. देखिए थोड़ा सा हम आपको हेल्प कर देते हैं. Forward. Okay. Why do you think so, Matthew?
Because, like, for example, if you have here N2 and H2, and if you apply pressure on it, it will, there will be more tendency for it to,
Combine.
become one. Yeah, combine. Yeah.
They will have more tendency to combine. Okay, fine. So this is fine. This is good. Okay. So you have N2 and H2, and that is why what will happen? They will combine with each other to form NH3 if you increase the pressure. The other way of thinking for this will be, So we will be taking help from the Le-Chatelier's principle. What does it say? It says that if I will change something in the equilibrium, if I disturb the equilibrium, then the system, it will move in such a direction that the change is minimized, So what are we doing here? Since we are increasing the pressure, since we are increasing pressure, the system would shift equilibrium in a direction where pressure is lowered. Okay, pressure is lowered. Okay, fine. Now how can I say on which side the pressure is lowered? And on which side, the right hand side or the left hand side? So you have to look at the number of moles, and number of moles of gases. Now I can say that in the reactant side we have gases, and the product side also we have gases. So can somebody tell me, where do I have more gas, in the reactant or in the product? Where do I have more moles of gases, the reactant or in the product?
The reactant.
In the reactant we have more moles of gases, and that is why the pressure will be more. And what the equilibrium will do, it will shift towards NH3, where we have only 2 moles, and that is why it will be lowering the pressure. Okay. So since we are increasing the pressure, the system would shift equilibrium in a direction where the pressure is lowered, Okay. So you can say on increase in pressure, the equilibrium shift towards that side which has less moles of gas. Okay, and vice versa. And you can say vice versa also. Achha. So that is why when you are increasing a pressure, it will only affect those systems which have different number of moles of gases in the reactant and in the product. Okay, gases and product. So for example, if I say let us write a question. The change in pressure will not affect which of the following? Reaction. Which of the following reaction? Okay. So let me write. We have this reaction. You can say you have N2. So both of these are gases. Okay. Also write information about gas now. All of these are gases. Okay. Choose one of those. Not one of those, but any of those which will not have any effect, and with the pressure will have not effect. No. So see, in A, we have 2 moles in the reactant, 1 mole in the product. So the pressure is going to affect here. But in B, we can see that we have 2 moles in the reactant, and also we have 2 moles in the product. Similarly, in the C also, you may see that it is 1 mole, 2 mole, but please remember that this is solid. It will not have any effect from the pressure. Okay, so we have 1 mole of gas, and here we have 1 mole of gas. So both B and C, they will not be affected by pressure. So you can write a note. For a reaction with delta Ng is equal to 0, the pressure has no effect. Okay, the pressure has no effect. Let me know if I can move.
Done, sir.
Done. Okay.
So,
One second.
Boli.
so in the third reaction, if we balance the reaction, it will be 2H2. Then there'll be 2
sorry.
moles this side.
Sorry. Thank you, Sarah. 2 moles, right? So in this, the number of moles are not same. So this is going to affect the reaction. This is going to affect the equilibrium. Okay. The next is effect of volume change. Effect of volume change. Okay, effect of volume change. Now in volume change, what is going to happen? So if I increase the volume, that means if I am decreasing the volume, that means I am increasing the pressure. So it will have same effect as that of pressure. Okay, not same, but the inverse effect as that of pressure. So since the volume, I can say, since increase in volume leads to decrease in pressure, and decrease in volume leads to increase in pressure, the volume change will have inverse effect as that of pressure, You can write here like this: volume. Two things can happen from volume. It can increase or it will decrease. It can increase. So if the volume is increasing, what is happening? The pressure is decreasing, right? So if the pressure is decreasing, then it will go towards where we have more number of moles. Shift towards more number of moles. More number of moles of gas. And if I decrease, that means I'm increasing the pressure, and hence it will shift towards less number of moles of gas. Done, guys?
Yes, sir.
Okay. Now, next is the effect of catalyst. Just write one line. I've written this previously also. Effect of catalyst. So you can write catalyst has no effect. Catalyst has no effect on the state of equilibrium. Okay, but the next one is important. Effect addition of inert gas. Effect of addition of inert gas. Done with effect of catalyst, guys? Yes or no?
Yes, sir.
Yes, sir.
Okay, fine. हो गया Matthew now? Done, Matthew?
Yes, sir. Yeah.
Okay, fine. So see, there can be two cases. Okay, when you are adding any inert gas, there can be two cases. Please don't write this. Okay, please don't write this. Let us first understand this. There can be two cases. What you can do, you can add in a closed vessel. Now, in closed vessel, what will be constant? What will be constant? Pressure or volume? Tell me. The volume is constant now. If I have a closed vessel, that means the volume cannot
The
change.
volume is constant.
Right? Volume is constant. So in this case, closed vessel, what is constant? Volume is constant. Okay. Now, let us suppose I have a closed vessel here, and I have some gases, and I have some gases. What is going to happen if I add more gas to here? What will happen if I add more gas? What will happen to the pressure? Volume will not change. What will happen to the pressure?
Pressure will increase.
Pressure will increase, right? So if I am adding, okay, if I add here, add inert gas, okay, that means if I'm increasing the number of moles of gases, then what I am doing, pressure is increasing, right? Pressure is increasing. Then what will happen? Equilibrium will shift towards less moles of gas. Okay, any problem? Any problem, guys?
No, sir.
No, sir.
No. So again, it is again going to pressure is increasing. Now we can have not a closed vessel, but we can have something in which we have, let us say, there is a rigid barrier and there is a flexible barrier. Now, so if you have a flexible vessel, that means the volume, now the volume it can increase. So in this case, what will be constant? The pressure will be constant. Okay, the pressure is constant. The pressure is constant. And in this case, what is going to happen? On addition of inert gas. Now, if this chamber was flexible, then if I added inert gas, then what it would have done? It would have expanded. Now, expansion means increase in volume. An addition of inert gas at constant pressure, the volume will increase. The volume will increase, right? Now, if the volume is increasing, what is going to happen? The equilibrium will shift towards more moles of gases. Okay, shift toward more moles of gas. Got it? हाँ जी, ये लिख लिया था आप लोगों ने? Tell me.
Yes, sir.
Okay, fine. I see this question. Describe the effect of addition of H2. If addition of H2 is happening, then I'm increasing the reactant here, right? I'm increasing the reactant, and then what it will do? The reaction will shift. There will be forward reaction. It will shift towards forward reaction, yes or no?
Yes, sir.
Okay. What about the next one? If I add CH3OH, then what is going to happen? What is going to happen if I add some product? Tell me. अरे क्या हो गया? Sorry, Ishma?
It will go in the backward direction.
Yes, correct. Backward direction. What happened, guys? Aisha, Samaira, Sarah, and Matthew. आपको नहीं आ रहा ये?
So I got it,
Sorry.
but I was confused.
No, ये होता है. Okay. See, if you're increasing something in the reactant, then it will go towards product. If you're increasing something in the product, it will go towards reactant. Okay. So you're increasing something in the product, then what will happen? It will go towards reactant. That is by backward reaction. Backward. Now, if I am removing from somewhere now, so what it will do? It will add. If I'm removing CO, then the system will add CO. How it will add CO? By backward reaction. Yes or no?
Yes, sir.
Now removal of CH3OH?
Forward.
Forward. Okay, forward reaction. Okay. Now similarly, you can also write for the question number, this is 29. I think 28 question is also similar. You can now do 24, 25, 26, 27, and 28. More, you can do more also. But please do at least these two, 26 and 20. Wait a second. 25, 25, 26, and 20. 25, 26, and 28. 25, 26, and 28. 25, 26, and 28. है ना? At least these question. नहीं, you have holidays now ना? आपका क्लास तो लेट है. नहीं नहीं नहीं, तब तो हम दे सकते हैं आपको, ज्यादा होमवर्क दे सकते हैं. Fine. Okay. So mostly your like whatever the effect it is done. Now we will be slightly moving towards new type of equilibrium that is known as the ionic equilibrium. But till here, can you please flip your pages in your notes and tell me if you have any doubt in any of the portion. I'm giving you 5 minutes, है ना? आप थोड़ा सा देख लीजिए अभी तक जो पढ़ाया हमने. You also look at some questions if you want. Then I can re-explain those things, or we can do something else. Otherwise, I will start with ionic equilibrium. यस, देख लिया आप लोगों ने? यस और नो गाइस? आयशा, हिश्मा, सारा से देख रहे हैं लगता है।
Sir, no doubt.
नो डाउट्स? ओके, आपने तो सवाल नहीं लगाए, सवाल आप कीजिए, उसके बाद डाउट्स आएंगे आपको। By the way, Hishma, this chapter was in your first term or your second term in your school?
Second term, sir.
Second term. अच्छा. States of matter was in first term, I guess.
No, sir, that was also in second term.
That was also second term. अच्छा, लेकिन आपका स्कूल बहुत फास्ट था, यानी कि they started very early. Okay. What about others? Aisha, Samaira, Sara.
No doubt, sir.
नहीं, I don't have any doubt. Yes, Aisha.
No doubt, sir.
No, no. Okay. Then we can move to ionic equilibrium, है ना? We can move to ionic equilibrium. अच्छा, by the way, Matthew. Yes, Matthew, are you there?
Yeah, sir. Tell.
हाँ, I'm saying ना, you have done some of the questions, yes or no? You have done na? So please
Yeah.
send those, okay?
I sent it, sir. Right before.
Actually, you have
class,
sent
I
it.
Yeah.
Okay, fine. Yeah, ionic equilibrium. Ionic equilibrium. So in this case now, we will be having the same thing: initial, change, and equilibrium. Okay, but in the description of equilibrium, as you saw, that there were few things that helped us. There was Kc that helped us in calculating the equilibrium concentration. There was Kc, there was Kp, and when you had pressure, then the total pressure of the system at equilibrium, it also helped us in calculating the partial pressure of the system. Now, similarly, in ionic equilibrium, we'll be introducing some helpers to calculate the concentration at equilibrium. So, main concern is what? To calculate the concentration at equilibrium. Okay, concentration at equilibrium. And let me now tell you, why do we calculate it? Okay, we calculate क्यों करना रहता है? Why do we need to calculate? See, when I start a reaction, what I will do, I will add some amount of A, and then I will add some amount of B. Okay, I will add some amount of B. Now, in this reaction, what it will happen? You will have A plus B, and it is giving me C. It is giving me C. Now, at this point of time, the reaction looks very fine. It means it's like reactant A and B have, and then in C is the product. C is the product. But what happens at equilibrium? At equilibrium, if I look at my container or the beaker, then in this I have A, B, and C, all of them. Some amount of A, some amount of B, and some amount of C. Yes or no, guys? Till here you understand? This is something that was always happening. We had some product and we also had some reactant. Now, to find now think about something. I always say this: there are some things which we can measure, and there are something that we can calculate. Okay, so whenever the measurement is very difficult, we go for calculation. Whenever the measurement is very difficult, we go for calculation. For example, let us talk about the initial concentrations. Initial concentration. So initial concentration, it is very easy to measure. Very easy to measure. Why? The only thing that we need to measure is what we need. We need a weight balance, something that can measure the weight. So I can get the grams of A, I can get the grams of B. Then we can get the volume. For that volume, what do we need? We need just the length, breadth, and height. Okay, 3 lengths. That means ruler, nothing else. You just need a scale and something that you can weigh something on. So you all know that all of these things, grams, that means the mass and the volume, we have some instrument from which we can measure the initial concentration. But think about calculating the concentration in this case, where everything is in a mixture. Can we measure it? Can you think of something? Like, first of all, what we can do is we have to separate this. Yes or no? I have to separate A from B and C. Then only we can calculate. Yes or no?
Yes,
Tell
sir.
me, guys. Hai now
Yes.
this is the reason we read the chapter equilibrium, that at this point of time it is very difficult for us to measure the concentration. The case at initial was very easy. We needed something that measure mass, and we needed something that can measure the length of the container that we have, and then from there we can calculate the volume. So we very easily we can find the concentration. But at equilibrium things become messy, and we have reactants and product, both of them in the beaker, and hence we are not able to easily measure the equilibrium concentration. Hence we go towards calculation, है ना? वरना इतना स्क्वायर रूट क्वाड्रेटिक रूट किसी को नहीं अच्छा लगता है. Okay, so it is not like things are like, it's not like science is made just to make things tougher. It's not like that. No, what we have done, we have now achieved an easy method for the calculation or the approximation of the equilibrium concentration. I know. Think about like what would have happened if we had to measure it only and there was no calculation method. Then you would have to invent an instrument that would separate all of these reactants and the products. Then only. So that is very, very, very expensive calculation. You are in 11th standard and you are calculating the equilibrium concentrations. You are calculating the equilibrium concentration. Okay, fine. Now let us move on to ionic equilibrium. So in ionic equilibrium, first of all, I will introduce a word which is known as electrolyte. What is electrolyte? Does anyone know? Have you been introduced to ionic equilibrium in your school? Matthew, Aisha, Hishma, Samaira, and Sarah?
No, sir.
No.
No, actually, you have not been introduced. Okay, fine. So, tell me what will happen if I have salt here. Okay, NaCl. Okay, NaCl. And I pass electricity to it. Current to it. Okay. Then tell me, will NaCl, will it conduct electricity? Solid NaCl. So let me tell you that solid NaCl, it won't conduct electricity. Okay, it won't conduct electricity. That much you take from it. So if I will have solid NaCl doesn't conduct electricity. Achha, what do you think about pure water? Can pure water conduct electricity?
No.
No.
All of you know now? Aisha, you have some other answer?
No, sir.
Same answer. Pure water will not conduct electricity. But what if I add here NaCl? What is going to happen? If I add NaCl, that means NaCl aqueous conducts electricity. Yes or no?
Yes, sir.
Yeah. Right. That means the aqueous NaCl, it is inherently different from the solid NaCl. And if it is conducting electricity, that means there should be something which is carrying charge. Right? There should be some charge carriers, and that is why the electricity can flow. The electricity can flow only if you have a charge carrier. Now, from this was the introduction of the concept of electrolytes. Okay, electrolytes. So please write, what are electrolytes first of all? Write a statement with me. The substances which conduct electricity in their molten states in their molten states or in the form of their aqueous solutions are called electrolytes. Then you can write now what are non-electrolytes. Substances which do not conduct electricity in their molten states or in the form of their aqueous solution are called non-electrolytes. So I think you can also do something.